Alright, give me the bloody book. I've got a couple just to throw around if you haven't seen. Has everyone seen? So I'm going to go on a little bit from Keith. What he spoke about, micros. So Arduinos, everyone knows what an Arduino is, pretty much. Yeah, the board with the micro put on it, set up, ready to go. So I'll hand a couple around, a couple of different kinds. The three different types. So there's 4 up on the board, a Uno on the top left, a micro top right, a nano bottom left, which is what I use pretty much for everything, and a mega down at the bottom right, which I don't use too big, too convoluted. There's differences between all the boards. So Keith was talking about all the I/O pins that the different microcontrollers have. So these boards that are going around, 3 of them are the same kind. Oh, we can get the arrow, I can't do that. But pretty much what he had was a spec sheet up of a microcontroller. This is a spec sheet, it's just a table of all the different specs on each board. You know, the connectivity, like USB connectivity, which is handy compared to with Keith's setup. You've got to talk to it via the it's like a serial connection. With all these Arduinos, they've got an onboard USB chip, so it makes it a lot easier to connect to. There's different amounts of I/O pins, different amounts of analog input outputs that you can use. So pretty much just a table giving I/O, communication, the power used, the clock speed, how much memory there is. Like I said, I use the Nano, which is a pretty small board for all of my projects, which I've got a couple sitting up here running, the SWR. There's one up here, we'll talk about it in a bit, but it's a GPS, it's a IARS mode. Doesn't really work that well inside. Anyway, minimum requirements for an Arduino at home. You need your Arduino of choice, USB cable to suit. Pretty much. You've got the Arduino on a breadboard and a pre-op computer.
Pentium 4s.
If you've got an old Pentium 4, you'll probably get away with it. That's an old IBM XT, it's probably not going to work.
Yeah.
But as you can see, P4, 256 meg RAM, 600 meg of disk space, as you don't really see anything with that small amount of hardware anymore. The Arduino IDE, which I'll open one up soon, I'll show you. It is the platform on the computer, like the program that we write the code in. So Keith was talking about all the different languages. The Arduino language is based around C++. It's a very readable, like human type language. I'll open one up in a minute. The program in the Arduino language is called a sketch. That's what we call them. It's just, I'll give you a sketch. I'll show you a couple of sketches in a minute. The code structure has libraries. So if I wanted to have a maths function in there, I would call on a maths library. If I wanted to run, say it's GPS, I actually use like a GPS library. That's pre-built libraries, what other people have made, and Simon, VK2KU goes and leeches off everyone. The difference with me and Keith writes his own libraries. Keith puts like his 1,100 pages of code and builds it himself. I go and cheat. But that's the whole idea about C++ and resourcing. Keith's way of writing software for his controllers is very, very, very efficient. Using C++, so Keith writes in assembly. C++, I wouldn't say it's inefficient, but it's nowhere near as efficient as Keith. get like assembly, like Keith writes in. So when Keith says he can fit a lot more information on his controller, that's because he writes in assembly. So for something that I use, like for this IARS setup, he could probably use a very small controller where I've used a 328p. I don't know what the model would be. You use something a lot smaller if you could write it on assembly. Problem is, all the libraries that I've gone and got to write that APRS, if Keith was going to write that, it would take him like a year.
Yeah.
Where it takes me, how long?
So that's the negative.
A month.
That's the big negative is that with using libraries, is that they're really there and they test it and debug. So you just download them and you'll put things up and running.
Yeah.
But you still need to know binary and hexadecimal.
Yeah. I don't know cheats with that. We'll get into that. In the program, I'll show you the program too. Like there's a code structure. So you've got like the global definitions. We've got the setup, and then we've got this part. And it's actually called a loop. Keith touched on the loop, but he called it the bit where it just runs over and over and over again and again and again. In the Arduino world, it's actually called loop. It's loop. It's just loops. So it's the part of your program, which is loops. So you can have subsets of other programs in your loop, and actually the loop just loops. So we'll go hit this button, loop that, and then loop that. And that's how it works. So in Keith's world, it's just operating recursively. In this world, it's just a loop, and that's how microcontrollers work. They keep looping, unless you pause it. But when you unpause it, it goes back to its loop. That's the whole idea of a micro. It's got a bit of a definition there. So we've got pin definitions. So there's those couple of Arduinos get around. There's all these pins on them, like A0, 1, 2, 3, 4, D. 1, 2, 3, 4. The digitals, analogs. There's a few other pins. When we get to the global variables that we define, int, an integer, a float, a double, they're all, when Keith was talking about words, what was the other data types that you were talking about? Yeah, but you have like a byte, a word with 16-bit. Yeah, so
a double word is 32.
Yeah, and that's what we're talking about here with ints, floats, doubles. It's like, it's getting those binary words and we're just making them into a bit of it's easy to read. There you go. So a loop. Every sketch has a loop. It's executed after the setup. Like I said, I'll open one up and I'll show you. In this example here, this is pretty much a whole program. That's a very, very basic one. You can see in the setup, I read it. So I'll start, I call for a serial port to begin. So serial begin, that's just a standard library call. It's just included in every sketch. You don't have to call a special library for it, it's just there. So I'll say serial begin 9600. So it starts the serial port on the Arduino at 9600 board. It's COM6, this is everything I'll tell you about that. Then it says serial print hello world. So what it's trying to do is print out to the serial port, which is COM port 6, just as the port that I set up, and 9600 hello world. There's nothing in the loop. So what happens all the time? Nothing. Setup runs once, and then the loop runs forever. So in setup, you can set up parts of your program, you can define variables, you can define constants. A constant's a variable that never changes, you can use it in the program. Like you can have a constant of 12 volts, which you can refer to all the time. But the loop repeats, the setup only happens once. So in here, when I open up the serial monitor, which we can use on the keyboard, use it for debugging programs. When I open up the serial monitor, restart the Arduino, this happens. The setup operates once, it starts the serial monitor, so it's connected to it starts the serial output, connected to the monitor, it prints that hello world, print it out, and jump into the loop. Nothing else happens. The loop's just running, but there's nothing to do. Does that make sense?
Yep.
Okay, cool. The serial monitor is something that I use all the time. Like I can write little bits of code into the program if I've got problems when I'm trying to debug a piece of software. I'll actually write, I can just even put a character, print this character when I get to here. And if I don't see a print, we're not jumping into that part of the loop. Or I can print out values. There's actually a serial plotter as well. You can plot graphs, but a bit more complicated. Serial monitor, here we go. Can monitor operations in the program in real time. I use it for debugging, like major debugging. Keith would do debug. Keith. The Arduino environment is very amateur, that's why I use it. Keith uses this like full space shuttle piece of software. I can't get around it. It's way past me. Serial displays, these are awesome. Add this to any project that makes it look pretty professional. There's a company that you would have seen me use them on a lot of my stuff. Keith uses them on all his pro stuff. But two kinds of displays, parallel or serial. On the left-hand side, there's a little black thing on the back. That's a serial backpack, and it talks this protocol, what Keith touched on, I2C, which is a Phillips protocol. 2-wire, power, 2-wire, and just talks on a serial bus. It's, I love it because it's simple. Keith doesn't like it because Keith he goes up again. He uses the parallel, but then on his same set of wires, he talks to like 8 different things, where I can only really talk to, I can talk to 2 displays, but Keith will talk to 20. I'm not smart like Keith.
Oh, come on.
But yeah, the most 2 common displays are 16 by 2, like this one, and 20 by 4. So, super easy, cheap as chips. Yeah, 16 by 2 you get for like $8, 20 by 4 I might get for $10. Makes your projects look professional. So what can you use these in amateur radio? So I made an antenna switch ages ago. I ended up throwing it in the bin because I never used it. It's just like cool. You press a button and click home. It's like SWR meters. So you've seen one. I've got another one on the boil. But that's cool. That's probably one of my favourite. I've got 2 favourite ones. The SWR meter, that's cool, and my APRS thing, which I've run for a long time. The SWR meter makes use of the analog input, which is analog or ADC input, analog to digital conversion. Keith talked about it. 10-bit. It means I can read 5 volts. I set the analog reference to 5, so then I can read 5 volts coming in from the SWR bridge, and I can read it at a resolution of 1024. So that's pretty fine. Like you can actually, depending on how much you're trying to read. If I'm reading 100 watts, it's 100 watts divided by 1024. That's increments I can read the power in coming in off the bridge. I did make a power supply monitor. I made this 60 amp linear, which is awesome. Had this power supply monitor. I ended up ripping it out, throwing it in the bin too, because I just turned it on and it just works. Why look at it and get fancy with it? But yeah, that was cool. You can use them for antenna tuning. Look, the sky's the limit. Get on the internet, have a look at what projects you can do with an Arduino. Sky's the limit. Something that Keith was talking about was that internal resistor, the internal pull-up. You can do it externally as well, which I do it externally a lot. Sometimes I do it internally. When you do it externally, when I do it externally, it's something I can see, something I measure. When I do it internally, if you have something go wrong in your program, or you forget to do something, things operate a bit unintended. That setup there, right there, is that setup on the bench, which is, look, you can go over, have a look, press the button. I've got a couple of LEDs so that you can see there's a 10k resistor to ground off pin 2. So what it's doing is pulling pin 2 down to ground. So if the button's open, pin 2 is reading 0. Well, it's a digital low. And in the program, we're looking at it, we're saying, if pin 2 is low, do something. Else, if pin 2 is high, do something else. And that's exactly what's happening with the software in this Arduino here I wrote yesterday. That's the end. So, I can show you, hopefully I can open up this bit of software. I'll show you there's a button.
Bill Gates.
Yeah, slide it from the sideways, mate.
If you go Alt space bar, and then you can move it with your keys.
What is it?
Alt space bar. It should display the menu. You can go move or move.
Yes. Alright. You still on that?
Just a question,
Yeah.
with the pin 2
Yep.
and the pin 13, pin 13 always seems to be the lead.
It is on most Arduinos.
Yeah, and if you use, you don't use any other,
Or you can use other pins.
but as long as you describe.
Yeah, okay, so have a look here.
Oh, updates.
No, so have a look here. We can see this is the whole program. This is the beginning of the program. So const int. So we've just defined a constant integer. That's called button pin equals 2.
Yeah.
So the button is wired into, like when we come down here a bit further, you'll see button pin, pin mode, button pin, so it's saying pin mode 2, so it's saying pin mode 2 is an input. Can you see that down there? Pin mode, there you go, button pin, so it's saying pin mode 2,
Right.
the pin on there, and it's calling an input. Pin mode lead pin is an output, so if you go with a lead pin, it'll be 13, I'd say, there it is, 13. And I've also just added another one in, 12. Same thing down here, I don't know if I actually declared that, I didn't have to.
So the underlined 1 on that instruction is indicates that you've got those two pins operating for LED.
One of them's an input,
Yeah, well,
that's a button, that's like the push button over here on this thing. And the other one is an output, which is an LED output. And you can see down here, I added a display on there as well, because I just wanted to talk about the serial display. Up here, I don't know what this resolution, see how there's a loop here?
yeah,
Starts here, so everything above the loop. Have a look, this is the setup.
Yep.
And then up above the setup, I've called it a library. Look at all this stuff over there. This is all this global definitions and what I'm calling, what we're doing. So I've globally defined these button pin, lead pin 1. So button pins on 2, lead pin.
no,
So-
what I'm getting at is that if you wanted to go a third LED pin, you would you'd call it the same as a constant integer. It'd be lead pin _2,
Yeah,
and then you dominate.
you can do whatever.
Okay.
But anyway, I just want to briefly show the program's got the definitions at the front. I've called a library. That's that liquid crystal. We've come down here. We've gone into the setup. I've started a serial monitor here. I've called these pins, inputs and outputs. I've started the LCD screen. I've cleared it. I've initialised it, turned the backlight on. And then when you get down to the nuts and bolts of the program, this is it. Button state. If it's high, turn left pin high. That's 13, and turn 12 low. So if you come over here, we're just about finished. So on your way out, press the button. You'll see when you press the button, one goes high, one goes low. When you let the button go, they flop, they switch back. Also, serial print button is on, so you'll see the screen flick up. This is a little bit of tidying up in the program. It stops the LCD wigging out and leaving some text on the display. And then we come down, else. So see I have an if statement. If button stays high, else do this, turn the light off. So really it's just saying if the button stays high, otherwise do something else. And that's pretty much it. There's not really too much more to it. Program's got a lot bigger. That's probably the smallest program I've got that I wrote yesterday. The program's got heaps bigger for the other stuff. That's pretty much it. Ask questions for sure. We're sort of running out of time, so I'll call it that at a night. Come up, press the button, see what it does. Sorry about the IARS. I do run around with that in the car sometimes to see it working. And there's SWR meter, which you all saw the other week, which is just an SWR meter. That's it. Thank you.
I think I'd like to get you back to some of your projects. Thanks very much. You're still driving a couple of teas, muffins out the back. We'll see you.